Welcome to Best Academic TV. In this video, we're gonna focus on exercise questions on Gauss law. Before we solve this question here, let's understand the question first before we solve the question. Please write. Okay. They said a hemispherical surface of radius 5 cm is placed in a uniform electric field of 250 Newton per coulomb. Full stop there. What is the maximum electric flux that can pass through the surface? Whenever we are asked to find electric flux, the law to apply to solve or to calculate for electric flux is Gauss' law. Please take note of that, okay? Now, calculating electric flux when electric field is given, we use this particular formula here. Solution first. All right, calculating the electric flux when electric field is given, we use this formula here. Phi is equal to class EA. I gave us various formula for electric flux in our last video. All you have to do is to revisit the video. All you have to do is to visit or revisit the video, depending on if you have viewed the video. You revisit the video to get most of the formula, while if you have not, you can visit the video to know more about Gauss law. Okay? So this is for electric field when theta is not given. The electric flux here will be equal to EA, where this E here represent electric field and this A here represent area, depending on the shape mentioned in that particular equation. Please take note. So if you look into the question here, they say hemispherical. So the area of hemispherical here, class, please take note of this. The area of hemispherical is the area of hollow sphere. Either I call it hemispherical or I call it hollow sphere, and both simply means half of a sphere. Okay. Now the area of hemisphere here, that is the area of hemisphere, is 2 pi r square. Please don't forget. All right. Now let's calculate the area of this hemisphere first. So the area here, let's impute. This is A, the area of hemisphere, 2 times 3.142 times the radius here. From the equation there, the radius is 5 cm. Convert to meter, that is divide by 100 to convert to meter. The radius given to us here is 5 cm. Convert this to meter here, this will be 0.05 meters. So replace it there, here, sorry. This will be 0.05 all square. When you punch your calculator here, class, you have this to be 0.0157 in meter square. Class, this is the area of the hollow sphere or hemisphere. Please take note. So we are given the area here after calculating. Okay. Now, from the question also, the electric field E is given to us 250 Newton per coulombs. All right. So electric field is given to us here. The area is being calculated from the radius. So let's plug in the parameters here. So our electric flux phi will be equal to, let's replace the value of electric field, which is 250, times replacing the value of area, which is 0.0157. Now when you punch your calculator, we have the answer to be 3.925. So let's know the unit from the formula. On the formula here, the unit will be this is Newton per coulombs, while this guy here represents meter square. So the unit of this is going to be Newton meter square per coulombs class. This is our answer here. Let's solve the next question here in regards to Gauss law. Please write question 2. Let's solve question 2 here on Gauss law. Before we solve this question here, let's understand the equation perfectly. And the question said a flat plate having an area, the area is given to us here, having an area of 5 meters square, is rotated in a uniform electric field whose magnitude is 7.4 times 10 raised to the power 5 Newton per coulomb. Calculate the electric flux through this area when the electric field is A, perpendicular to the surface of the place, okay, B, parallel to the surface, C, makes an angle of 75 degree with the plane of the surface. All right, they gave us a question and they gave us some conditions on how to solve the equation. Okay, now let's solve the question here. Solution first. Okay, the first here, we list out the given parameters first. Sorry for this. We list out the given parameters. That is given parameters. Okay, now let's list out the given parameters for guidance here. So A, which is area, is given to us as 5 meters square. It's already given to us here. So the electric field E is given to us as 7.4 times 10 raised to the power 5 Newton per coulombs. And we're asked to find the first condition here. The first condition here, A, we're asked to find the electric flux when the surface is perpendicular. Okay, now when the surface is perpendicular, theta is equal to 90 degrees. So there's an involvement of angle here. And whenever there's an involvement of angle, to calculate electric flux, the formula will be equal to EA cos theta. Please don't forget. EA cos theta. So let's replace this here, class. E is given to us as 7.4 times 10 raised to the power 5 times A is given to us as 5 times cos 90. So when you point the calculator here, class, cos 90 will give us 0 here. Multiply everything by 0 here, it will be 0. Please take note of that, okay? So this is our answer here. This is our answer and the units. Please take note. Now the next condition here, B, that is they say parallel, and the word parallel also involve an angle. It means that the theta is given to us as the angle theta is given to us as 0 degree. Please pay much attention here. The word perpendicular and the word parallel indicate an angle. When the surface is in perpendicular, it means that the angle is 90. Why? When the surface is in parallel, it means that the angle is 0. Please take note of that, okay? So let's solve for the flux, electric flux. For the electric flux here, it will equal to, class, the formula EA cos theta. This is the formula for electric flux when angle is given to us. Please take note. So let's input here. E is given to us as 7.4 times 10 to the power 5 from the equation, times area is 5 from the equation, times cos 0 degree. Okay, now punch your calculator here. because 0 will give us 1. 1 times this 5 times this will give us that is 37 times 10 raised to power 5. Please take note. Times 1, that is for this here, don't forget. So when you convert everything to standard form, our answer will be equal to our answer will be equal to 3.7 times 10 raised to power 6 in Newton meter square per coulomb. Please take note. This is our answer here. So let's solve for condition C when theta is given to us as 75 degrees.